So as I discussed now, hopefully the notion of stability is somewhat clear to you, and I think in lecture number 13 or 14, probably 13, I have already discussed the notion of positive definiteness and other things. Now this one, it's like this one, now this time I am going to discuss that the tools using or means depending on our previous understanding. Now, one more thing I would like to discuss here, that how can we exploit something. Uh, Before I proceed, I just want to show you very basic manipulation. So today we are going to discuss the Liapunov. So what we are trying to do here is that v dot x is equal to, if we vx, first of all think about vx. Vx is what? First, before we find out vx, we must be very careful and means conscious about the definition of vx, or we can write this is vx because vx is positive definite, such that you can further add vx is greater than 0 for all x not is equal to 0. Now, sorry, here it should be norm for all norm x not is equal to 0. Now, another one here, that what is one question that should come in our mind, that can we figure out v dot x directly? Like, is Vx is a direct, means Vx exhibit a direct dependence on t? The answer is no, because Vx is only a function of x. However, x being a function of t due to the state transition, Vx is implicitly dependent on t, explicitly dependent on x. So what we can do is that we can write v dot x and we can apply our very old mathematical, means what we studied, like we can figure out that kind of, say if our x is having n component, like x is equal to x1, x2, xn transpose, then we can write it like del v del x1 dx1 dt plus del v del x2 dx2 dt. So basically what you will have here, you will have something like here it is f1x, where x1 dot is equal to f1x, x2 dot is equal to f2x. Now as we are considering it autonomous system, we are not mentioning t over here, so you get fnx. Now see what we are doing here. It's very simple thing, that this whole thing can be written like del v del x f of x. Actually, I wish I can write it all the time using the bold letter because it is a vector valued function, but it's a bit tiresome and will consume unnecessary time, which is not worthy of means spending time on this particular petty issue. You are mature enough to figure it out, right? Now we are ready to state the theorem like let, as we are quite aware that we can do an equilibrium point shift for an autonomous system, and there is no harm that assuming for the given system the origin of the coordinate system, that is x is equal to 0, be an equilibrium point for x dot is equal to fx, and d belongs to Rn, be a domain of containing that origin let v of now what is d? D is where your fx is Lipschitz, be a continuously, oh god, so let x is equal to 0 be an equilibrium point for x dot is equal to be a continuously, here I was continuously differentiable function and v0 is equal to 0 and v of x greater than 0 for all x belongs to D, uh, and Vx greater than 0 for all x belongs to D, like writing this, or other way you can write for all x uh, not is equal to 0, or you can restate this statement like Vx greater than 0 for all x belongs to D such that norm x not is equal to 0. Both statements are having equal, means identical meaning, and have equal impact on this definition. Basically, we are trying to claim Vx is a like positive definite function within our domain of interest D. Now, what we can write, then this equilibrium stable, moreover, if v dot x is less than 0 for all x belongs to d minus 0, then is asymptotically stable. Right. So the idea or the notion of this problem is very clear, that if your V is positive definite and it's having, oh sorry, I just forgot to write one part, that then x0 is stable when yeah, I just forgot it to write for normal stability. You must have this line there itself. Just a minute, give me a minute, I'll do this for you. Actually, this subject is so means engrossing and means deserves such a like attention that it is somewhat difficult all the time to. If v dot x uh, less than is equal to 0 for all x belongs to D, no need to mention D minus 0 itself, because we know that it's going to be 0. So then our x0 is stable. I forgot to mention this line. Now we are all set. And then if this is true, like if v dot x is negative semi-definite, then it will be just stable, and if it is negative definite, then it will become asymptotically stable. So that we need to show in during our means we have to prove it. But before proving, we want to give you a geometric representation of this whole thing, that you could figure it out. Like, okay, before we give you that geometrical interpretation, let me proceed with that means proof. like what it states, x is equal to 0 be an equilibrium point for this a domain containing origin. The equilibrium point let v be a continuously differentiable function, and now it is your job to tally that whether a continuously differentiable function is Lipschitz continuous, or Lipschitz continuous is a stronger condition than that of having continuous differentiability, or vice versa, or the one implies other. Which one is this case that you may investigate? But if the very basic essence of SIL means this statement is that V be a continuously differentiable function. Now V naught is equal to 0, Vx greater than 0 for all x, and Vx greater than 0 for all, means these are the two identical statements as I have discussed. If V dot x less than is equal to 0 for all x belongs to D, then x is equal to 0 is stable. Moreover, if V dot x is negative definite, this statement actually literally you can say that V dot x is negative definite, or time rate of change of V dot x is negative definite, then it is asymptotically stable, right? Now, so let us start with that. Uh, like we have our statement here. Now, let me write. Let us consider given and epsilon greater than 0. Let us choose sorry, like the bound on R is that R, even we are assuming that R tends to 0, but R cannot identically be equal to 0, right? Now we are defining a ball BR. Try to follow me very closely. At least this I found this kind of discussion quite enticing, but at the same times uh, sometimes incomprehensible and difficult to understand. So until unless you pay full attention, you may get distracted. So BR obviously belongs to D. The way we have defined it, see, there are two ways to define a ball. Here this ball is such that you have the most outer surface of the ball is also present. So this is a ball. Now if we just slightly modify this definition, then actually you have to leave, or means you have to, you will not be able to consider the outer surface of the ball. The sphere you cannot consider that contains the ball. Rather, you will have something that is inside that sphere that is still in the shape of ball, but that then in that case the ball can be anything, right? Means it can be a ball very close to your surface, or it may be a very small ball very close and concentrated near the origin. So anyway, let us consider here. When I will discuss more on topology, you will get to know more about this. Let alpha be something, a point where we are having then we can write that how to write that alpha greater than 0, who ensure that alpha greater than 0. See, alpha is defined as the minimum value of Vx when you are defining it along the surface of the ball. Right? Mod x is equal to r means you are varying the x on the surface of the ball. Now, if you still have that notion of your what to say, that positive definite means x1 square plus x2 square kind of things in your head, then obviously it will become difficult for you to digest that how some point can have so minimum value of Vx, right? But let me give you one example and I hope that will make sense. uh, like uh, mm, now just a minute. Let me figure out some function for you. Uh, Give me a minute. Okay, here we go. I have figured out one function like square by say so this is also a positive definite function. Now here you can see that now let us consider a ball here, or we can have this also like so. Undoubtedly, this is a positive definite function, and just let us check whether it gives us when x1 and x2 are not is equal to 0, then uh, yes, then we have that one. But where we will get, say this is a ball of radius 1. Huh? So along this one, that along this circumference, what you can write is x1 square plus x2 square is equal to 1. However, what would happen when you will reach here at this point? There, say, let it make it say point 99 minus x2 square. Perhaps you will realize that at this point you will have, like, why I am giving you this kind of example, to just to make sure that you develop a notion that it is not only about uh, means being positive definite or negative definite, or it is not only means whenever we talk about positive definite, we this kind of functions come in our mind, but not only this is the type of positive definite function, this is also a positive definite function by its own. However, you can see that when we are here, then probably you will have a value, or we can more precisely we can write it like this be say rho, and rho very close to r. Now you can see that if rho close to tends to 1, sorry, rho tends to 1, then you can have the minimum value here when you are having x1 is equal to 1 and rho tends to 1. But there is a constant that rho cannot be is equal to 1. Now this function by its own it's positive definite, but one thing it's quite clear that even you are moving on the ball on the surface, you are moving along a path that is equidistant from your origin, still your function Vx can vary. And what is purpose of doing all this mumbo jumbo is to make you understand that alpha do not have a notion that even if we are considering the most outer sphere, the shell that contains this ball, then our Vx will be constant on that shell. Vx may be constant, may not be. If it is constant, like if we have this Vx like this, then obviously there is no question of minimum or maximum arises. Vx will remain constant on that ball. Is it so? It will remain constant on the ball surface everywhere. But that doesn't make means it the previous statement invalidate. Like alpha is equal to minimum of Vx. If it is a constant one, then also it will have a minimum value. That will be same as its maximum value. That's a different story. We are interested with minimum value. Now, as Vx is positive definite, obviously when you are not see the way we have defined R, I would like to show you the way we have defined R. See how we have defined R. R tends to means R is in that semi-open set 0 comma epsilon, like the maximum bound of R is epsilon, but R can be as small as 0 but not identically equal to 0. Now with this we can write that we can take beta belongs to open set 0 comma alpha, such that the region of this is defined as So what is beta? Beta is all the point that contains all such x for which your Vx is having value minimum or equal to the um, value of Vx which you had when you are traversing on the outer shell, on the surface of the outer shell. This alpha you got when you are means roaming on the outer shell of the ball, and now this beta is defined as it can vary between a very small number close to 0 but not exactly equal to 0 to alpha, where alpha is the minimum value of energy function when you are roaming on the surface of the ball. Now with this we defined another region, that is omega beta, capital omega beta, where this omega beta contains all x belongs to Br such that Vx less than is equal to beta. So what we can see that if we try to have a geometric interpretation of this, we can draw it like, say this is our D. Now inside that D we are having a ball, then inside that we are having another ball, basically they are not actually a circle also, that is you can see that the way we have drawn it. Then we have another ball. Now let me draw the axis. Let me use different color to make you understand. Right. Now who are they? They are this one, this outer wall is BR, this one is what we defined here is omega beta. Now what we can have, like this omega beta is interior of this BR. How and why? Because BR is formed by all such x. Now you may think that or you may have a problem in digesting this fact that omega beta is interior of this ball BR. Now this you can show by contradiction, like suppose if this omega beta is not inside or interior of BR, then there will be point P lies on the boundary of BR. At this point, what you will have Vp greater than is equal to alpha greater than beta. But that you will, but for all, if you recall, for all x belongs to omega b, this region, Vx is less than is equal to beta. So there is a contradiction. Now hopefully you do not understand the contradiction. So let me once again go back to the definition of 2. This is the BR. How BR is defined, that epsilon greater than 0. Now we select a semi-closed interval 0 comma epsilon. Now where this R can be as small as very close to 0 but not exactly identically equal to 0, that is I have written here. So we have defined a ball BR where this mod x is less than is equal to R, belongs to D. Now we are considering an alpha. What is alpha? Alpha is that value of minimum mod x is equal to R Vx. Then we are considering alpha greater than 0, obviously, because mod x is okay. One question, that how can we make this inequality like alpha greater than is equal to 0? What modification we need to carry out? Think about it. You need to make this one a closed interval. Had you include 0, like R, if you allow R to be 0, then mod x will be 0. Then you can make alpha is equal to 0 rather than alpha greater than 0, because even if it is a positive definite function, by virtue of its definition, if you go back, it is 0 at origin, right? So until unless you allow x to exactly means lie on your origin or overlap with your origin, you cannot have your Vx greater than means equal to 0. So you cannot have your alpha, which is the minimum value of Vx, that is equal to 0. So alpha is bound to greater than 0. Now it is like you are having, if you still have problem, let me show you geometrically what is BR or what BR could be. BR could be some concentric circles, like this could be BR. The outer value of BR is that it is can have epsilon, but there is no such means inner bound that this one can become very close to origin, but only requirement that if I try to zoom the origin, then you will see that say you have different BR like this is one BR, then you have a smaller BR, then you have a smaller BR, smaller, but whatever small you make it, it cannot be identically overlapping on your origin. It must be a circle that is having a radius even if infinite small but not equal to 0. That is the beauty. So that is your beer. Now what I am trying to prove here by saying so many things here, that I am claiming this region, this closed region omega b will be interior to this BR. Now note that BR is defined based on x and omega b is defined based on v. So obviously your by normal understanding one question will arise that who that is omega b is forefather servant of BR, that BR will means claim you must be interior of means my area. No, not like that, but there lies that this omega b is defined in such a way that it is alpha, right? And then this alpha is such that it is beta is equal to 0 comma alpha. Now this alpha, where you get alpha, that is the minimum value. Now if you make it like obviously as alpha greater than 0, beta means beta is also something that is means defining your Vx upper bound. Beta cannot be cannot include 0 because Vx by virtue of its definition cannot give you 0 value, whatever small value it gives, but always give non-negative positive value not equal to 0 in all other point except origin. So beta cannot see in book it is written in one line, but as below average people like me, I take this some time to understand and realize. But I find that once I realized it, that makes everything very easy to understand and visualize in my mind. So beta, this we cannot make it close. So this must be open. Now, why it cannot means if we do it like this, then what change will happen? Then the change that you can expect here, that this inner closed region denoted by omega b may touch beta r at some point where you are having your BR is giving you the minimum energy point alpha. But as you have excluded that by writing it or by defining beta that doesn't include this alpha in its definition, obviously you will have omega beta. Now if you make it very close to alpha, then what you will have? You will have this omega beta like a region, it may be very close to your where is that? Where is my cursor? It becomes very close to like this, very close to some point, but it cannot touch. It is not possible for this inner curve to any way or anywhere touch the circle defined by this beta r. But there is you may ask me that why then this omega b is of such irregular shape, it is not circle. Mind my friend, this omega b definition is based on your energy value. It has nothing to do with norm of x. However, this one we are doing it like it is x1, it is x2, and I hope you are mature enough to generalize in means for any value of x. Just a minute. Now it is quite clear that it cannot touch the outer region, or means outer shell defined by your BR. Now what I am trying to show you, it's something like if we are all set and we are convinced with the argument, then this omega b, this region has the property that at means any trajectory starts at omega b will means like will be always there in omega b. How am I so sure about that statement? What I am trying to say that like the set defined by omega beta has the property that any trajectory starting at this omega beta. Oh God. So the set omega b has the property that any trajectory starting at omega beta will always stay in region omega beta for all t greater than is equal to 0. Now, how am I so sure of all the trajectory must be confined within this region omega beta? Because I have not yet forgotten that statement v dot xt is less than is equal to 0, and that implies, see the beauty, vxt is less than is equal to vx0 for all t greater than 0. And we can take conveniently, we can take that this, if we make sure that our vx0 is such that this x0 falls under this region defined by this omega b, it is impossible for that trajectory to leave that one. So we'll get something vx0 is less than is equal to beta. What is beta? If you have forgotten, it is very often you forgot everything. Then let me remind you, beta belongs to 0, alpha. What is alpha? Alpha is something that is minimum of like alpha is minimum of mod x is equal to r v x, like this is actually alpha is the minimum value of vx that you can get on the outer shell. Then you are having a beta, like you are actually have a tendency to find out first minimum value of your energy function over the outer shell defined by your that norm. Okay, what is R? Now here let me also define R. R is something that is right. So it is very clear that, and why it is epsilon, we are considering that for epsilon we are confident that for this epsilon we have a delta greater than 0 inside which our state trajectory will satisfy the condition of epsilon delta stability. So this is how that whole thing works. Now we get that this omega beta, can we call this omega beta is a compact set? Omega beta is closed and bounded by the way we have defined it. The way we have defined it, or it has been defined, it implies that omega beta is closed and bounded. If you are not sure that why omega beta is closed and bounded, let me tell you what defines your omega beta. Your omega beta is this one, that the set of all x that is with Vx less than is equal to beta. So now it implies it is having this beta point like beta of Vx. So corresponding this beta, you will have another x. Like if you still have doubt, you can consider that terminating x will be like x is, if you operate it in reverse way, then it is v inverse beta, that is x beta, right? Now how you to get that, that we are not always sure, because quite often this v is something that is function, it is many to one, so it is not always that easy. Like many to one by means many to one, what I am trying to say, it's a simple thing, that, oh god, yeah, here you can see that I have drawn it somewhere, I just couldn't locate it. Anyway, just let me draw it here. Like suppose we are taking x1, x2, we are taking Vx is equal to the most gentle one. Now everywhere you will get it is equal to 1. Your Vx is equal to 1 constant. Now which point, now if you try to obtain a reverse mapping, so basically Vx is doing what? Vx is a function, in this case it is like this is the case in this way, like this one, this entire thing, if you consider mapping, then it is like the real line R, or you can say the extended real line R. So this entire means all the points on Vx will map at 1. So this is a many to one mapping, and this should not be forgotten. So it is clear that like we may not be able to find out the way I have suggested somewhere, value of beta and explicit value of beta by doing such inversion of V is not possible to find out, but obviously it will give you some idea that it cannot go beyond that region, right? It will give you that means even if you take that example like x1 square plus x2 square is equal to 1 and vx is all over constant over that means circle, circumference of that circle. Now here one thing is quite clear that if I tell that Vx has to be 1, then whenever you will means try to do some kind of inverse mapping, you can claim that I will have my point anywhere on the circle circumference but not beyond it, means not outside of that circle, right? So that is very important. So that is why it is bounded, and obviously this set is closed because we know the terminating value of omega b is included here, right? That the maximum value of omega beta and the minimum value of omega beta is inside it. So it is obvious that omega beta is closed. Just a minute. So it is very interesting to note that the whole thing is like it's bounded and it's closed, like it includes the two terminal point. Now I would like to take you back to our previous theorem. I'm not sure where I have written it, or had I think I had discussed. I think I have discussed it. Otherwise, it is a great problem. If I have not yet discussed it, then I need to discuss it. Which one? Yes, this one. Let f t comma x is continuous in t and locally Lipschitz in x for all t greater than is equal to t naught, and for all x belongs to d in the Rn, let w be a compact subset of d. Now who is going to play the role of w? That is our very own omega beta, such that it contains x naught belongs to w. Every solution of x dot is equal to f of t comma x with this lies exactly in w, then there exists a unique solution that is defined for this. Now we will take or exploit this theorem to figure it out that how the our like it is going to stay in our omega b. See, the way we have defined omega b, it is closed and bounded. So omega b will play the role of w. Now any trajectory will start in omega b, will lie there, means will remain there for all t greater than 0, provided the initial condition is in omega b. So as your Vx is continuous and V0 is equal to 0, there exists delta greater than 0 such that all norm x equal to delta implies omega less than beta, then obviously beta delta is contained in phi b, and phi b is contained in br. So it's so clear that x naught is equal to x naught is contained in beta delta, because beta delta is a subset of omega beta in such a way that x it contains and now we are having x naught is contained in omega beta, and therefore all xt will lie in omega beta for all t greater than equal to 0. Now what is needed that okay, or we can say that if mod x naught belongs to less than delta, then it implies you are having xt that is always less than r, and r is less than is equal to epsilon for all t greater than is equal to 0. This is one part. What is the second part? The second part is like we have to prove that it will go to 0 as we like that the part of asymptotic stability. Now I will discuss this part in our next session. Like otherwise this particular video lecture will extend to more than 1 hour, which I don't want. But my BTech students are demanding for having a entire content in a single lecture, so I delivered them a video of 5 hours, 6 hours length. If you want, we can have that kind of things, or otherwise I'll divide it in class wise 1 hour, or nearly 1 hour segment, and then you can watch it. So you may let me know about your convenience, and accordingly I'll shoot the videos.